In the diagram, if the bearing of Q from P is 50 degrees, look at it, and the bearing of R from Q is 130 degrees, they were asked to calculate to three significant figures PR, the bearing of R from P, and we calculate the shortest distance between point Q and PR, and hence the area of the triangle. Now, in this question, it is unique where because we are given the diagram, we are to solve, or we are not to draw the diagram again, okay? So, from the beginning, we are told that the bearing of Q from P is 50 degrees. So, you can see it here, 50 degrees given. Then, we are told that the bearing of R from Q is 130 degrees. And this is the 130 degrees given to us, all right? Now, for us to find PR, there is something that we need to know. Now, this is P. The side that is facing P is termed small p, and the side that is facing Q is small q, and the side facing R is written as small r. So, invariably, we now know that PR is the same thing as the small q, all right? So that is what you are to look for. Now, please just watch and see what I'm going to do here. Now, if this place is 50, it therefore means this place is 50. And the reason is because they are alternate angles. Now, the whole of this place is 130. So if I want to get this particular place, it is 50. How? Because it is a straight line, so adjacent angles, so we have 180 minus 130, and it will give me 50. All right, so you can see now that I have gotten everything here. So here is going to be what? 100 degrees. Now, since I've gotten this, I can actually find my Q using the knowledge of cosine formula. Now, one thing about cosine formula is, let me just remind you of this. If you have a scaling triangle, okay, let's say we have this triangle, here is A, and here is B, and here is C. Now, of course, this is small b, this is small a, and this is small c. If I'm to calculate A, so A squared is going to be B squared plus C squared minus 2BC then cos A. Of course, since we know this, we can actually have an expression for my Q. Now, let's get Q. Now, do you know that Q squared now is going to be R squared plus P squared, okay, minus 2 into RP, then cos Q. Now, we have everything there except for the Q that we are to look for. Therefore, we'll now come down to substitute the values. So we have Q squared is equals to, we know R is 8, so we have 8 squared, then plus P, which is 13, so we have 13 squared, minus 2 into 8 times 13, all right, then we have cos 100. Now, I need you to follow me to understand what I'm going to be doing here because it's very important. So Q squared is going to be, this is 64 plus 169 minus 2 into 8 times 13 is 104. Then I have cos 100. Cos 100 is minus 0.1736 using our calculators. So take note of that. Q squared now will be equals to, now I can now add this, which is 64 plus 169. We are going to have 233. All right, then now watch what is going to happen. You see, I'm going to multiply everything here, but this minus and this minus, when multiplied, it becomes plus. Please take note of this. It's very important because students do have issues with that. All right, now multiplying everything there is going to give me 36.1088. Now Q squared will now be equals to 269.1088. Then q squared, okay, not q squared again, q is going to be square root of 269.1088, so that we can find our q to be 16.4045. Now remember, we are asked to leave it to 3 significant figures, so q will be approximately 16.4 kilometers. So we have dealt with the first question. Now the next question is for us to find the bearing of r from p. R from p. So we'll come to the diagram. Where is r? This is r. R from p. So therefore, the bearing will be from the north. Look at north of p. We are going to have it like this, all to this line. So this is the bearing of r from p. Now to find this, let me go over to have a sketch of the diagram, then explain further. Now check the screen and you will see what I'm talking about. Now the bearing of r from p is everything here. That is from the north of p down to the line that joins r and p. So how do we do that? We take note that this place is already 50 degrees. We know it. Now, the issue is for us to find this, all right? If we can find this, then we'll now add it to the 50 to give us the bearing. So we are going to use sine rule. And let me tell you something about sine rule. Sine rule is this. If I have sine A all over A is equals to sine B all over B is equals to sine C all over C. Now, in some books, you see it written as A over sine A is equals to B over sine B is equals to C over sine C. It is all the same. Now, it depends on what you are given. Then you just do the combination. Like in this case, you see, I'm looking for P. So I can now say sine P all over small p is equals to, where do I have complete? It's Q. So it's going to be sine Q all over small q. So you can see the only unknown that I have here is the angle P. Therefore, I will now have it as, and going further with the calculation, I will cross multiply so that I have 16.4 times sine P is equals to 13 times sine 100. All right. So that sine P will now be equals to 13 times sine 100 is 0.9848. Then this will be all over 16.4. All right. So sine P will be equals to 0.7806. So that my P is going to be sine inverse of 0.7806. Now, P will now be approximately, approximately 51.3. All right. So this is the value of P. It therefore means that the bearing of R from P will now be equals to 50 degrees. Please let me show you. Now, if you check it, you see, is this 50 degrees plus what we found here, all right? So it's 50 degrees plus 51.3, which will now give me 101.3 degrees. So that is the bearing. So I'm done with that particular question. So let's quickly move to the next question. Okay, on the screen we have the next question, which says we should calculate the shortest distance between Q and PR. So this is Q. This is Q here. Q and PR, the shortest distance will be this line. That is the shortest distance. If you check, now take note that this place is not 90 degrees. This place is not 90 degrees, so take note of that. So therefore, you can see that our unknown in this case is this x. That is the distance. So let me take it down and sketch it so that we can solve it well. Now this is the sketch, you see, but to find x, we must find this particular angle. All right, then when you use sum of angles in a triangle, you'll find out that this particular angle will be equals to 78.7. all right, it's not hard to get that. And once we have that, then we'll now use our sine rule again, so that we are going to have sine 51.3 all over x will now be equals to sine 78.7 all over 8. Then we cross multiply. Once you cross multiply and you rearrange, you find out that x will now be equals to 8 sine 51.3 all over sine 78.7. Now, this when solved will give me that x is equals to 6.3635, which x is approximately 6.36 kilometers. So I've solved this now, but there is something that was said again in this question. It says, and hence we should find the area of the triangle. That is this particular triangle that we see. Now, to find the area of this triangle, we are going to make use of the formula where we are going to have two sides and a given angle. Now, in this case, we have x to be 6.36, all right? So, therefore, what we are going to be using to solve this will be area is going to be half, okay, times 8, then times 6.36, then times sine of the angle between them, which is sine 50. Now the area now will now be equals to 1 over 2 times 8 times 6.36 will be 50.88 approximately. Then times the sine of 50 is 0.7660. All right, so therefore the area now will be 19.487, which area it is approximately now going to be 19.5 kilometers square. Okay, so that is the area. So we've succeeded in solving everything about this question. Thank you so much. And don't forget to subscribe.